As part of this topic, let us understand how to aggregate the data using Spark SQL. We can either perform global aggregations or aggregations by key. Here are the examples for global aggregations: getting total number of orders, getting revenue for a given order ID, getting number of records with order status either completed or closed. And then when it comes to aggregations by key, we typically use group by. And here are the examples for aggregations by key: getting number of orders by date or status, get revenue for each order ID, getting daily product revenue, where order date and product ID will serve as keys. We will see these examples and then we'll actually come back to the other concepts related to performing the aggregations, especially the rules while using group by. First, we will be performing the global aggregations. To get the number of orders, either we can say select count of order ID from orders like this. When you use count, you can even provide the literal such as 1. Conventionally, when we actually started working with the databases, it is a good practice to use a literal rather than specifying the column name. Now it doesn't matter. Either you can use literal or you can specify one of the columns in the table using which you want to get the count. Now if you want to get distinct count on a specific field such as order date, you can use count of distinct and you can specify the field name like this. It will give us the number of distinct dates we have as part of the orders. You can also get revenue for a given order ID. When we say for a given order ID, it will reflect as part of the where clause, and in where clause we can have the condition we are looking for, which is nothing but order item order ID, and whatever order ID you want to pass, you can pass. And then as part of the select clause, you will be having the function sum on the field using which you want to get the revenue or the metric. If you want to round it off to few decimals, you can use this non-aggregate function round on top of the aggregated result and you can take it further. Now if you run this, it will give us the revenue for the order ID 2. If you want to get the count of orders based on status completed or closed, this is how the query look like. As part of the where, we can actually specify this condition order status incomplete comma closed, and as part of the select clause we can have the count function to get the number of records with order status is either in completed or closed. Now comes aggregations by key. First example which we want to see is nothing but number of orders by date, and this is how it will look like. You will specify the keys as part of the group by, and if you want to display the key also, we have to specify as part of the select clause. But if you try to specify other columns than whatever you have specified in group by, then it will not work. It will start failing. You can only have those columns which are in group by and aggregate functions when you try to perform aggregations by key. You cannot have non-aggregate columns or functions as part of the select clause when you try to use group by. That is the rule you need to follow. Now let me run this and you should be able to see the results here. We got the date and count for each date. When it comes to the other example where we want to get the count by status, this is how it will look like. We just have to say select the key using which we want to get the count, which is also used as part of the group by, and the aggregate function count to get the count by status. And these are the results we can see with the status, the count by status. So here the condition is not right. We have completed, not complete. That's why it is only showing 7556. However, if you look at this count by status, complete is 22,899 and closed is 7,556, which means approximately 30,000. Now if we run this, you can actually see the correct results, 30,455. Okay. Now let's talk about revenue for each order ID. So we have to use order items table. It have order ID, and order item subtotal is the one which can be used to compute the metric, which is nothing but revenue for each order ID. So we have to use order item order ID as part of the select clause, and then the aggregate function. You can give the alias like this. The aggregate function is nothing but sum of order item subtotal. You can use functions such as round to fine tune our metric output. And then as part of the from, we have to specify the table. As part of the group by, you have to use the key using which you want to compute the metric. In this case, the key is order item order ID and the metric is order revenue. And we are using order items, and you should be able to see the results here. Now let us see how to compute daily product revenue. When it comes to daily product revenue, we need order date from orders, order item product ID, and order item subtotal from order items. As we need fields from two different tables, we have to use join to join these two datasets, and then we have to use group by order date and order item product ID. Using these as keys, we should be able to perform the aggregation by applying sum on top of order item subtotal to compute daily product revenue. Also, we just want to consider complete or closed orders. That's why we have this additional where condition. This will give us the daily product revenue. focus on the group by, we have order date and order item product ID from orders and order items respectively, and then focus on select clause. In this select clause, we have the fields which are specified in group by, and then we have an aggregate function which is nothing but sum, and we have provided alias revenue to get daily product revenue, and we should be able to see the results. Now, using this as a baseline, if you want to get only those products on daily basis whose revenue is greater than or equal to 500, some people tend to use this approach where they use this alias as part of the where condition and say greater than or equal to whatever value against which you want to compare. Some people might use this function itself. Either of the approaches will not work. It will fail. You can see that this one is failing, saying mismatched input blah blah blah. Even if I replace this with revenue, which is nothing but alias for this, even that one will fail. First let me go back and see that everything looks good here. Yeah, we have the exact expression copied, still it did not work. And if I undo this and if I go back to revenue, even this will fail. You can see that it is failing with some error. However, typically it fails with a different error, but this time it is failing with some other error. For now, let me delete this and see if this is working first. Okay, there is some other syntax issue in this. So let me copy this and let me paste. This is running. Now, some people tend to use and revenue greater than or equal to 500 if you want to see daily product revenue where each day the product is generating more than $500 revenue. So if you are interested only in those products who are generating more than $500 revenue, some people tend to use where condition like this. Now you see it is saying cannot resolve revenue given input columns blah blah blah. You can also try to replace the revenue with this. Even then it will not work. It is saying some other error. So this is not the right syntax to solve the problem such as get daily product revenue where the revenue is greater than or equal to 500. Instead of using where condition like this, the way you should be able to solve the problem is by using having clause like this. Having goes with group by. Without group by you cannot use having. If you want to apply any filters on top of aggregated results, you have to use having clause after group by, and you should be able to solve the problem. The reason why the where condition on revenue or on this expression will not work is because of the order of the execution. First, the query will be executed from the from clause, then it will go to the where clause, then it will go to the group by, then it will go to the having, then it will go to the select clause. As this expression is primarily used in select clause, you cannot use this expression or alias as part of the where clause. That's why this one is failing and this one is working. Anytime if you have to apply filters after performing the aggregations on aggregated results, you have to use having clause, not the where clause, to add additional filters. That being said, now let's review the rules while using group by. We can have the columns which are specified as part of group by in select clause. On top of those, we can have derived columns using aggregate functions. So in our example, as part of the group by, we have order date and order item product ID. You can use either order date or order item product ID or both as part of the select clause. We are having both here. Now, on top of these things, you can only have the derived fields using aggregate functions. If you have derived fields with non-aggregate functions, then also it will fail. So on top of those fields which are specified in the group by, you can only have derived fields which are derived using aggregate functions. Derived fields from non-aggregate functions cannot be specified as part of the select clause. That is the rule which you need to follow when you are using group by. That being said, we cannot have any other columns that are not used as part of group by on derived column using non-aggregate functions. I'm reiterating the same point which I have highlighted a couple of times earlier. We will not be able to use aggregate functions or aliases used in the select clause as part of the where clause. I have already demonstrated that. For example, if you want to get all the daily products where revenue is greater than or equal to 500, you cannot have either this alias or the expression itself as part of the where clause. That is the rule which I am emphasizing here. If you want to filter based on aggregated results, then we can leverage having on top of group by. Specifying where is not an option. And the typical query execution is nothing but from where group by. If you have having, it will also execute having. Then it will go to the select. That is the reason why specifying the conditions against the derived fields using aggregate functions in where clause will not work. That being said, so far we have seen how to project the data, how to filter the data, how to perform the joins, and how to perform the aggregations as well. And we even took care of performing aggregations after joining the datasets. As we have covered most of the basic transformations, now it is time for us to understand how to sort the data.